Sometimes when a star collapses into a supernova, it releases an intense, narrow beam of gamma rays. Gamma-ray bursts often last just a few seconds, but during that time they can release as much energy as the Sun will produce in its entire lifetime, making gamma-ray bursts the most powerful explosions ever observed in the universe. They are so intense that, if pointed at the Earth from even the most distant edge of our galaxy, they could easily cause a mass extinction, possibly obliterating all life on the planet. It's thought that a gamma-ray burst may have caused the Ordovician extinction around 440 million years ago, which wiped out 85% of all species at the time. Clearly, the farther away a planet is from gamma-ray bursts, the better its chances of harboring advanced forms of life. In a new paper, scientists have shown that the gamma-ray burst risk to life favors a universe where all objects, like planets and gamma-ray bursts, are relatively far apart. And the main factor that tells how far apart everything is in the universe, or in other words, how things are spreading out and moving away from each other, is dark energy or the cosmological constant. One of the biggest unanswered questions in cosmology is why does the cosmological constant have the particular value that scientists observe? Einstein initially devised the cosmological constant to be like an anti-gravity force, so that a larger value means that the universe is expanding very rapidly and objects are being pushed farther apart from each other. A smaller value means that the universe itself is smaller and objects are somewhat closer together. Currently, the value of the cosmological constant is estimated to be about 10 to 123. Researchers have placed upper bounds on this value. It can't be more than 10 to 120 or else galaxies and other structures could not form because their matter could not have gotten close enough together. But so far, no research has been able to place a lower bound on the value. It's not surprising that Earth seems to occupy a favorable point in the researchers' simulations, a place with minimal exposure to gamma-ray bursts, and at a time with many hydrogen-burning stars like the Sun, along with a high average metallicity. This special place and time may help researchers search for other possible locations of life in the universe. We would like to further refine this limit and extend the range of parameters, beyond just the cosmological constant, that influence the rate of gamma-ray bursts, and investigate their implications for the possible locations of planets that can harbor life, Piran said.